Here's problem 2927. A proton is accelerated from rest through a potential difference of 2.5 kilovolts and then moves perpendicularly through a uniform 0.6 Tesla magnetic field. What is the radius of the resulting path? Well, the change in potential energy of this proton is going to equal its charge times the change in voltage. And that is going to equal 1.6 times 10 to the minus 19 for the charge. And we're going through 2.5 kilovolts. So this is equal to 4 times 10 to the minus 16 joules. In this case, the change in kinetic energy will be equal to this change in potential energy, and that also will be 4 times 10 to the minus 16 joules. Since our initial kinetic energy is 0, we start from rest. That means that our final kinetic energy will be equal to this change in kinetic energy. Our final kinetic energy is 1/2 mass times the velocity squared, so the velocity of this proton will be equal to 2 times the kinetic energy divided by the mass square root. That's going to be 2 times this 4 times 10 to the minus 16 joules over the mass of the proton, 1.67 times 10 to the minus 27, all this square root, and that's equal to 6.92 times 10 to the 5 meters per second. That's the velocity of this proton. Nice to know. Always wanted to know that. We want to find the radius in the 0.6 Tesla magnetic field. That should be equal to its mass times velocity over its charge times the magnetic field. So the radius is equal to the mass of the proton, 1.67 times 10 to the minus 27, times the velocity we just found to be 6.92 times 10 to the 5 over the charge of a proton, 1.6 times 10 to the minus 19 coulombs, and the magnetic field is 0.6 Tesla. So this radius is equal to 0.0120 meters, or 12 millimeters. So the radius of the circle that this proton moves through in this magnetic field as it's perpendicular to the magnetic field is 12 millimeters.